Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the boiler corrosion. Boiler corrosion can be defined as the decay of boiler material by the chemical or electrochemical attack of its environment. So, boiler corrosion can be defined as the decay of boiler material by the chemical or electrochemical attack of its environment. So, it is nothing but the corrosion of the boiler material. So, especially this boiler material undergoes corrosion due to the presence of dissolved oxygen or due to the presence of dissolved carbon dioxide or due to the formation of acids from dissolved salts. So, what are the major causes for boiler corrosion? So, the major causes of boiler corrosion includes three important factors, namely dissolved oxygen or dissolved carbon dioxide or due to the formation of acids from dissolved salts. Dissolved salts means which are responsible for the hardness of the water. So, let us see how they are responsible for the boiler corrosion. So, the first factor is dissolved oxygen. In general, 8 ml of oxygen will be present in the dissolved state for liter of the water in the dissolved state, and hence it is called as dissolved oxygen. So, whenever oxygen is present in the dissolved state, especially in the boilers, high temperatures will be maintained. So, at high temperatures, this oxygen readily attacks the boiler material. Boiler material means that is nothing but iron and results in the formation of ferric hydroxide. So, at high temperatures in the boilers, the dissolved oxygen readily attacks the boiler material and results in the formation of ferric hydroxide. So, once ferric hydroxide is formed, it readily converts into rust. So, ferric oxide will be formed, that is nothing but rust. So, whenever ferrous hydroxide is formed, it is readily converted into rust. In that way, due to the presence of dissolved oxygen, the boiler material undergoes corrosion and it is called as boiler corrosion. Then, how to prevent boiler corrosion? So, simply by the removal of dissolved oxygen, we can prevent boiler corrosion by the dissolved oxygen. So, for that purpose, we can use sodium sulfite or hydrogen, or we can also use sodium sulfide. So whenever these reagents are added to boiler material, then what happens? They selectively reacts with oxygen which is present in the dissolved state. So whenever sodium sulfide or hydrogen or sodium sulfide is added to the boiler water, it readily attacks the dissolved oxygen and results in the formation of corresponding salts, and thus the dissolved oxygen will be removed from the water. In that way, the boiler corrosion due to dissolved oxygen can be prevented. So, whenever if we use sodium sulfite, hydrogen or sodium sulfide, they reacts with dissolved oxygen and no longer dissolved oxygen is available. Hence, the boiler corrosion due to dissolved oxygen can be prevented. The second major cause is due to dissolved carbon dioxide. So, especially the boiler water consists of hardness producing salts. So, always in boilers, high temperatures will be maintained. Under such conditions, what happens? Especially the calcium bicarbonate, which is responsible for the temporary hardness, undergoes decomposition and results in the formation of calcium carbonate, carbon dioxide and water. In the similar way, the magnesium bicarbonate present in the boiler water also undergo decomposition and results in the formation of magnesium hydroxide along with the liberation of carbon dioxide. From these two equations, very clear that so whenever the boiler water is heated to high temperatures, the temporary hardness producing salts will be converted into corresponding dissolved salts with the liberation of carbon dioxide. Now this carbon dioxide readily combines with water and results in the formation of carbonic acid, and this carbonic acid is responsible for the boiler corrosion. So whenever there is a possibility for the formation of carbonic acid, it attacks the boiler material and responsible for the boiler corrosion. So in order to prevent the boiler corrosion due to carbon dioxide, we have to remove the carbon dioxide from the water. So for that purpose, we are having one best option for the removal of dissolved carbon dioxide, and that is whenever ammonium hydroxide is added to the water, it readily reacts with carbon dioxide present in the water and gets converted into ammonium carbonate, and thus no longer dissolved carbon dioxide is available, and thus the boiler corrosion due to dissolved carbon dioxide can be removed. And the third major reason for boiler corrosion is formation of acids from dissolved salts. Dissolved salts means especially the salts which are responsible for the hardness. So for example, when we consider magnesium chloride, undoubtedly it is responsible for the hardness. So at high temperatures, it readily reacts with water and gets converted into magnesium hydroxide along with the formation of HCl. So whenever there is a possibility for the formation of HCl in the boiler water, then what happens? It is a strong acid and it readily attacks the boiler material. So here, due to the formation of the strong acid HCl, it readily attacks the boiler material and results in the formation of ferrous chloride. And this ferrous chloride reacts with water and results in the formation of ferrous hydroxide. Once ferrous hydroxide is formed, it readily reacts with oxygen present in the boiler water and results in the formation of rust. In that way, due to the formation of acids from dissolved salts, it is responsible for the rusting of boiler material, and that is nothing but boiler corrosion. So these are the three major factors responsible for the boiler corrosion. Now we have to discuss how to prevent boiler corrosion. So the major task is prevention of boiler corrosion. So boiler corrosion can be prevented by using frequent blow down operations. That means whenever there is a possibility for the formation of sludge, that must be removed time to time from the boiler water. Second option is, before using water in the boilers, it should be softened. So we have to adopt softening methods. And the third option is, it is better to use corrosion inhibitors such as sodium phosphate or sodium chromate, etc. So by the use of corrosion inhibitors, the boiler corrosion can be prevented to certain extent. This is all about the boiler corrosion and its prevention. Thanks for watching. Have a nice day.